in principle, you have 5 presentations. So each presentation is 15 minutes plus 5-minute questions. I would like to go ahead and try to confirm if the presenters are here for the moment, because we will start in 2 minutes. So I see that the first presentation is from Bornia Jemai, Ali Farida, and Olivier Debauche. Is any one of the speakers here? Okay, let's go to the second presentation is from Manal Nejari and Abdulwafi Mazian. Are you here, please?
Yes, I'm here.
Okay, thank you. The third presentation is from Li Dong and Yongxin Lin. Are you here? And then the presentation number 4, Al-Hadrami Sheikh Turad.
Yes, I'm here. I'm with Professor Mohsen Laij.
Okay, thank you. And then the presentation number 5, Rashid Ayat Moulay, Abdul Latif Al Ghazi, and Zain Al Abidin Al Abdul Ali. Are you here?
Yes, I'm here.
Okay, so we have, at least for the moment, we have 3 confirmed presentations. Let me again check the first one. So the first one is from Bornia Jemai, Ali Frihida, and Olivier Debauche. Is any one of the presenters here? Hello? Because I see here. Okay, so I think I see one of the speakers here, so I'll try to chat with him or her. Okay, so good. So we have the first presenter, Jemai Bornia. Let's start. So as I mentioned at the beginning, we have 15 minutes for each presentation and 5-minute questions. So what I will do, you start your presentation and I will tell you that you have 5 minutes. When you have at 5 minutes from the end of your presentation, I would tell you that you still have 5 minutes. So please go ahead. I would like to invite Bornia Jemai to talk about or to present her work on deep learning and TensorFlow for tracking people's movement in a video. Please share your screen and the floor is yours. Please share your screen because I tried to talk to you, but it seems you don't listen, you don't hear me. Can you all hear me, please? Because it seems she cannot hear me.
Yes.
Okay. Yeah.
Yes.
So
Yes, yes,
Bornia,
we can hear you.
so Bornia, can you please start your presentation? If not, if you have technical issues, we will go to the second speaker. Okay, so since there is no reaction, and in order to avoid any delay, so I would like to invite Manal Najari and Abdelwafi Mazian to present their work on Sahara LSTM, an enhanced model for sentiment analysis and of hotels Arabic reviews based on LSTM. So Manal, can you hear me?
Good morning. Yes, sir.
Yeah,
I can
yes.
hear you.
Please, good morning. Please go ahead and share your presentation.
Okay. Give me a second, please. I will share my screen.
Okay.
Can you see the presentation?
Yes, yes, yes. Please go ahead.
Okay. Good morning, everyone. My name is Manal Najari, and I'm PhD student in the Computer Science Laboratory of Mohammed First University in Oujda. Today, I'd like to talk about an enhanced model for sentiment analysis hotels Arabic reviews based on LSTM. So,
I think we lost Manal. Manal, can you hear us?
we? Yes?
We cannot, at least I cannot see your screen anymore.
Okay, I'll try. Sir, can you see the screen now?
Yes, yes, please go ahead.
Okay. So, good morning, everyone. My name is Manal Najari, and I'm PhD student in the Computer Science Laboratory of Mohammed First University in Oujda. Today, I'd like to talk about an enhanced model for sentiment analysis of hotels' Arabic reviews, which is based on LSTM. So, my presentation is divided into 6 main sections. I'm gonna introduce my work, then expose the research question. The second section includes a methodology overview. The third one is about the user dataset. In the fourth part, I will speak about the proposed approach. Then I will turn to results and discussion, and finally conclude presentation. Let's start with the motivation of this work. why choosing this topic and why working on Arabic reviews. The main reason behind this choice is that nowadays people all around the world are using more and more internet and then producing a huge amount of information, which could be very useful in different domains, such as decision making or product feedback analysis. Moreover, the Arabic language is becoming popular among internet users, being the official language of 27 countries and spoken by more than 422 million people in the Arab world. As you can see in this map, the world internet users were estimated to 4,929 millions of users by October 2020, and this relates to what I was saying earlier. As I said before, here are some sentiment analysis applications. It could help us explore other opinions, leading to innovation and creativity, making some strategic decisions for some governments in politics, for example, and also satisfying customer by improving quality of services for some businesses and organizations. Let's now expand on our research question, which is how to optimize the use of recurrent neural networks in sentiment analysis of hotels reviews written in modern standard Arabic. So in this work, we implement a type of recurrent neural networks, which is LSTM, long short-term memory, to perform sentiment analysis of online hotels reviews written in modern standard Arabic. In this area, a novel approach is proposed, and we adopt two-stage classification approach. For that aim, and in order to gain time in the building dataset stage, we use in this work a part of the dataset built by El-Sahar and Baltaji, shown in the reference below. This dataset covers 4 domains: hotel reviews, restaurant reviews, movies reviews, and product reviews. In this work, we use only the hotel reviews dataset, which is entitled HTL, which comprises about 15,000 Arabic reviews scrapped from the Arabic version of the TripAdvisor website. So for each review, we have the text of the review plus the rating offered by user. The rating shows the sentiment expressed by a reviewer. It was extracted and normalized into one of 3 categories: positive, negative, or mixed. So, based on the previous dataset, our SAR LSTM model is built as shown in this figure. SAHAR, which is the abbreviation of Sentiment Analysis of Hotels Arabic Reviews. As you can see in this figure, we adopt two-stage classification approach. In the first stage, we use dimensionality reduction as an information retrieval technique to select the most relevant features in our HTL dataset. For the second stage, we perform reviews classification using an implementation of recurrent neural networks, which is LSTM. So let's first define dimensionality reduction. It's a typical step in natural language processing studies, and especially for sentiment analysis tasks. It allows the transformation of data representation into shorter, more compact, and more predictive one. Here we use 2 classes of dimensionality reduction techniques, which are extraction and feature selection. Feature extraction aims to transform high-dimensional data into lower-dimensional feature space through the application of some mapping. One of the most popular feature extraction technique is latent semantic analysis. The objectives of this technique is to analyze and identify the pattern in unstructured collection of texts and the relationship between them. overcome two of the most important keyword queries used to select the most relevant features contained in HTL dataset. Concerning the feature selection technique, a subset of original features is selected, and only the selected features are used for training and testing process without taking into consideration the removed features in the competitions. We used also the chi-square technique, which is a large used feature selection method that evaluates features individually by computing chi-square statistics with respect to the classes. In this work, the features with high chi-square can be considered relevant for the sentiment classes. And let's take a look at this chart. The top 4 most useful features selected by the chi-square test are رائع, سيئة, ممتاز, which are mostly from positive and negative reviews. So we can see that the higher the chi-squared score of the term is, its informative quality grows up. You can notice also that some features selected by the chi-square test are the stop and the negation words. So in our future works, we intend to perform some pre-processing techniques in order to remove useless words by taking into consideration the negation words that can affect the polarity of the review. So after speaking about the first stage of classification, which is dimensionality reduction techniques, let's now expand on our LSTM classification model. By the way, it's kind of RNN model with one LSTM, one embedding, and one dense layers. It's, by the way, to design our LSTM model for Arabic sentiment analysis, we used the Keras library, which is an open source neural network library written in Python. Our input is a sequence of words, and outputs is binary sentiment label. Let's turn now to the results and try to discuss them. So after converting long vector to short vector based on feature extraction and feature selection, and training our LSTM classifier on our HTL dataset, this graph shows clearly the results of dimensionality reduction techniques led on our dataset. In terms of accuracy, it's observed that the dimensionality reduction techniques achieve good performance with positive reviews more than the negative ones. The accuracy obtained with our dimensionality reduction model is 83.60%. Now, and after combining the dimensionality reduction model with our LSTM techniques based on LSA and chi-square, an accurate performance is obtained. We can see in the chart that accuracy achieves 90% for negative reviews and 93% for the positive ones. So that brings me to the end of my presentation. In the future work, we would like to experiment LSTM with different architectures, layers, and parameters, using some pre-processing techniques to reduce noise in our dataset before the classification stage, developing and building our own Arabic reviews dataset and the multi-domain one, not limited to Hotels reviews, training our model using cross-validation, and developing a web tool with user interface based on our proposed approaches, allowing sentiment analysis of online reviews in different websites and blogs. To sum up, we proposed in this work an LSTM-based model for sentiment analysis of Hotels Arabic reviews called Sahar LSTM. We revealed that the LSTM model can be combined with LSA as feature extraction method and chi-square as statistical feature selection technique. Accuracy achieves 90% for negative reviews and 93% for the positive ones. Thank you for your attention. If you have any questions, I'm here to answer. Thank you.
Thank you very much. Yeah, thank you very much. Any question from the audience? So actually, I have a quick question. Is there any reason why the negative reviews get a smaller score, 90%, and even in one of the slides it was 77%? Is there any reason for that?
Actually, it depends on the data set, because we cannot see that there is a reason behind this results. I think it depends on the size of the data set and I think so.
Okay. So I think this should be maybe this should be highlighted. Is that the accuracy is just due to the data set because you have more positive remarks than negative reviews, right?
Excuse me, I didn't understand the question.
So you mean what the reason behind the fact that you have less accuracy for negative reviews? It's because in your data set you have more positive reviews than negative reviews, right?
Yes.
Okay. Yeah, so I think this should be clear. You should highlight it if you are giving another presentation. You should highlight it because this is interesting also. Okay. That you don't have enough data.
Okay.
Okay. Any other question? If not, I'll thank you very much, Manal.
Thank you.
I'll go to the next presentation. Which is Bornia. Bornia, can you hear us? Will you be able to present? Okay, she cannot hear us. Okay. So then we go to the third presentation. Is there any one of the presenters? No, we cannot hear you. Bornia, we cannot hear you. So I think you need to fix the problem. So in order not to waste time, I would go ahead with the third presentation. So is there anyone from the presenters, Li Dong, Yongjin Lin, and Yixin Bang, on medical image registration via similarity measure based on convention on CNN? Is there any one of the presenters present? Okay, so if not, I would go to the next presenter, which is who is Al-Hadrami Sheikh Turad.
Yes, I'm here, sir.
Okay, so your presentation is on survey of automated deep neural networks implementation on FPGAs. Please go ahead.
Okay. I will try to share my screen. Can you hear me?
Yes. Yes.
Okay, I will share my screen. So, good morning. I'm Hadrami Sheikh Turad. Today I will present our article, Survey of Deep Learning Neural Networks Implementation on FPGA. Presentation outline. First of all, the introduction. It's a motivation slide. Then we will talk about the background. It's about some definitions, the problem, and the solutions in this article. After that, we'll see the precision format. It's a presentation of data like parameters and weights. here we will see the types of hardware architecture used by the frameworks. In these slides, we will see what is the design space exploration, the parameter of interest, and the types of exploration. Then we will talk about the software design automation and the hardware design automation. After that, the mapping strategies used by the frameworks. After that, we will discuss the relevant metrics and summary of all the features of frameworks. Finally, conclusion and perspectives. In the last few years, deep learning has contributed in many fields of artificial intelligence. It's everywhere in our daily life. When we connect to the internet, in our house security, in the medicine, it's everywhere. There are many types of deep learning neural networks divided by their different architectures and layer types. The widely used types are deep neural networks, the DNN, and the convolutional neural network. In the deep neural network, we have the input layer, output layer, and the hidden layers between that. These hidden layers are fully connected layer, which mean all the output units from the layer are connected to each input unit of the next layer. In the convolutional neural networks, the types of layer are convolutional and pooling, and finally we have fully connected layer. The convolution is sliding small matrix on the image to produce an output feature neuron value to assemble it in matrix called feature map. The pooling reduces the size of pooling is reducing the size of convolutional feature to decrease the computations required to process the data through the layer. And finally, we have the fully connected layer. The deep learning models use a huge amount of data, like weights and parameters. So to achieve a good accuracy, to achieve a good accuracy rate, we need a lot of time, as shown in the image. Here we have to achieve 6.29 error rate, we need 1 week of time. So to solve this problem, there are many suggestions to solve this problem. And we will talk about that in the rest of the presentation. But the most important solution is the implementation on the FPGA. FPGA, field programmable gate arrays, is an integrated circuit that can be customized for a specific application using hardware description language. The recent search works shows that the FPGA plays a significant role in accelerating deep learning neural networks. The implementation of deep learning neural network models challenge. The implementation of deep learning models on the FPGA have 3 main challenges, which are requirement of a significant amount of storage, external memory bandwidth, and computational resources. Here, as shown in this image, we have a number of weights on the order of millions, and the operations, we have giga operations per second. We have here some models of deep learning models like VGG16, ResNet. Deep learning model uses a huge amount of data like weights and parameters. The studies shows that they have some of redundancy, which mean we can delete this data without reducing the accuracy. This process is the compression step. There are many types of compression methods, but pruning method and quantization are the most used and the most efficient. The pruning method is removing the less contributing weights by removing the connections or the nodes. The quantization method is reducing the number of bits required to represent each weight. We have a deep compression. combine the pruning and the quantization method plus Hoffman code. It's a very efficient method as shown in the table. Here we have the network, original size, and the compressed size, and the compression rate is by dividing the original size on the compressed size. We have 14 times, we have 10 times. Here original accuracy and compressed accuracy, even better. Here we have even more accuracy than the original accuracy with size very low. Here a table regroup the frameworks presented in our article and the interface. Here it's TensorFlow, Torch, they are Python frameworks, and the supported type of deep learning neural methods, neural networks, and the supported device. Here the compression method supported by the frameworks. There are some frameworks not support the compression methods. Here the precision format. We mentioned the precision format mentioned in our article is a floating point and fixed point. The floating point consists in sine, exponent, and mantissa. Fixed point format consists in sine, mantissa, and shared exponent. The precision format used by the frameworks are fixed and floating point, both the fixed and floating point. And the dynamic fixed point is a variant of the fixed point format in which there are several shared exponents. It's a trade-off between the floating point format and field point format. The frameworks use two types of hardware architectures, streaming architecture and single computation engine. In the streaming architecture consists of one distinct hardware block of each type of layer, convolutional, non-linear, pooling. These blocks are chained to form a pipeline as shown in the image. This approach uses the parallelism between layers through pipelining and enables concurrent execution. In the single computation engine is a matrix multiplication unit which uses to execute the model layers sequentially. Here we have the model layers sequentially. The control and scheduling are performed by a software in this architecture. The main purpose of the design space exploration is to match two spaces, the space of the problem or the conception and the space of application objectives or constraints. This analysis is based on the parameter of interest, which are frequently the latency, throughput, and power efficiency. There are many methods and types of exploration. We have architectural exploration or algorithmic exploration. Like we have a lot of methods of exploration like synthesize, then compare, estimate, then compare, and we have a heuristic method like simulated annealing or taboo search. Yeah, we have design automation. We have software design automation. It's to try to run different networks on the same hardware accelerator by simply only changing the input. And we have hardware design automation generates different hardware designs according to different deep learning models. The difference between these works is the granularity of instructions. Mapping strategies. We have start from scratch strategy. It gives much more flexibility for the mapping procedures to be applied since the architecture of the model is not fixed at this point and can be modified after that. Or pre-trained model. Here the customization preferred than flexibility, and more restricted concerning the number of available tools that can be used in the process, since the architecture and the internal structure should remain as intact as possible from the beginning. discussion. The evaluation of the effectiveness of mapping deep learning neural networks to FPGA is based on many metrics such as the accuracy, the latency, throughput, and the portability of the implementation. Here we have the framework FIN. It's tried to trace off the very high throughput and low latency by restricting its focus only on the binarized neural networks. We have DNN Weaver. It gives priority to the portability and the compatibility of the design, but the throughput is limited without consideration for the latency. We have Alamo is one of the better frameworks due to the combination of high throughput and low latency. But it's limited to only the Intel FPGA. FPDNN is optimized for high throughput and adopts uniform quantization as specified by the user. LeFlow and Haddock 2 use a direct mapping approach in order to mapping the exact model to the hardware. DL2 HDL and HLS4ML, it supports many neural networks such as LSTM, convolutional neural network, and deep learning neural network, but it's limited to Xilinx platform. Here we have summary. This table regroup the features of each framework. Here we have the framework, the models supported by the frameworks, convolutional, recurrent, deep learning, the devices supported by the framework, the architecture. S is streaming architecture, or SCE is single computation engine. The precision format, fixed point or floating point. Here we have design space exploration. We try to resume the design space exploration used by each framework in one word or sentence, like algorithmic, deterministic. Deterministic is use the type of synthesize, then compare to be sure you implement the exact design. Here we have roofline and analytical models. In this method, there are a stop condition or limit not to pass it in the comparison between the two spaces. Here we have exhaustive over analytical model. It's like the roofline, but we can pass the stop condition. And we have heuristic methods like simulated annealing or taboo search. The heuristic method is we try to produce a good enough solution, but not the exact solution. And we have finally the compression methods supported by the frameworks. Conclusion. This paper presents an updated survey of the automation mapping of deep learning neural networks to FPGA. We have some frameworks in 2019, 2018. We have many metrics evaluation between the frameworks like latency, throughput. We have like a perspective, a good benchmark between all the frameworks. We use a widely used deep learning models on the same hardware FPGA. After that, we do the benchmark between all the models. Like future works, we have the development and creation of prototype of mini compiler, which have as input graphic presentation of deep learning model. And finally, we have the implementation automatically on the FPGA hardware. So it's our future works. Thanks for your attention. Thank you.
Thank you very much. We have a question from Dr. Mohsin. So his question is, according to you, what is the best platform?
It's not here. We have several platforms which it's good in terms of latency. Other in the term of portability, but it's not. We don't have a one platform. It's generic for all the types of deep learning and all the types of hardware FPGA. So we can do trade-off. It's based on our interest. If we want a good latency, but we trade off that with the throughput, etc. So it's not, we cannot say this platform is the better or the most efficient. It's depend on our objectives.
Okay, thank you. Any other questions? If not, I would like to thank the speaker. Thank you very much. Okay. And I would like to go for the next speaker. So it seems that Bornia solved her problem. Please try. Bornia, can you hear us?
Yes, sir.
We can barely hear you. Can you speak louder, please?
Okay. Now you can hear me?
Yes, now we can hear you. Okay. Please share your screen. So your presentation is on deep learning and TensorFlow for tracking people's movement in a video.
So you can see the presentation?
Yes.
Okay. Can I start?
Yes, please go ahead. You have 15 minutes.
Okay. Good morning, everyone. My name is Jam'i Bornia. In the next few minutes, I will briefly present my work titled Deep Learning and TensorFlow for Tracking People's Movement in a Video. First of all, we start by the plane, which is made up of 5 parts. We will introduce the work, then the related work. In the third section, we will present the algorithm that we proposed. In the fourth section, there are the experimentation and the results. And we finish by conclusion and the perspective. Lately, there has been an increase in video data that has been noticed because it generally gives more information in a simple way, but the manner used to exploit them still human supervised. It also comes down to technological advancements such as cameras, storage devices, and scanners. Exploiting large video database is becoming a very active field of research. The published works present algorithms or tools developed while deep learning technology and TensorFlow are considered to be a very effective tool for video processing. Deep learning technology presents a set of automatic learning methods that allow data and knowledge modeling with a high-level abstraction. The difficulties arise when looking for an appropriate representation for the visual content that reflects the semantic of the video. It is uneasy to extract semantic content directly from raw video data. This is because video is a temporal sequence of frames with explicit relation to its semantic content. Also, we introduced TensorFlow, that is Google's open source machine learning framework for data flow programming across a range of tasks. Nodes in the graph represent mathematical operation, while the graph edge represent the multidimensional data array communicated between them. There are many features of TensorFlow which make it appropriate for deep learning. In this paper, we present an approach that allows us to detect objects existent in each image using the label image package.
If the object and person exist, an XML file is attributed to each one. XML files are converted in CSV files to use TensorFlow package. Then we will convert CSV file to TFR record format. In this stage, once the above is done, there should be two new files: train record and test record. At the end, we train the model. Afterward, when the model is trained and evaluated, we trace motion in the test part. Before presentation, our approach, we present some algorithm in the related work such as histogram. It is an algorithm to extract object and person from an image. Most images used today are recorded in 8GB. They have 3 components from each pixel representing the intensity in red, green, and blue colors. The 3 component diagrams are the description of the image in input and can be used to perform object detection. They represent the number of pixels contained in the image for prices and intensity of color. Several works have been done to study the similarity of images. RCNN, region-based convolutional neural networks. It consists of the selection of about 200 regions with color, texture, and the intensity as the criteria in order to estimate a high probability of presence of a desired object. This algorithm is broken down into 3 main steps. The selection of region of interest, the application of the convolution layers and the proposed regions, the optimization of the position thanks to a regression algorithm on the boxes delimiting the detected objects. YOLO, the third algorithm, is YOLO-U only. Look once, it is an image classification and object detection application based on a totally different approach. This application uses a network of neurons of to the complete image. This network divides the image into regions and predicts to the boundaries or segments and probabilities for each region. The segments are weighted by the predict probabilities. Be the algorithm of motion detection, such as feature detection. The first step of this method is to detect features that are good to track corner. This is very efficient method thanks it to invariance to rotation. It is based on 5 steps: special derivative computation, Maximus selection, small invalues removing, invalues selection. Movement future tracking, optical flow computation. Optical flow method is applied to track the previously detected corner. As a result, this method provides for each corner a related velocity and angular direction of motion. The algorithm consists of 7 steps: that pyramid construction, pixel matching over levels, local gradient computation, iterative loop match and temporal derivative computation, optical flow computation, estimation correction, and the iterative loop, result propagation, and the pyramid loop. So our proposed approach is to create a method capable of extracting the movement from a video, extract the keyframe of the video, detection of the existing object in each keyframe via a label image package. If object or person exists, an XML file is attributed to each one. XML files are converted to CSV file to use TensorFlow package, and we will convert CSV file at the end to TF record format. In this stage, once the above is done, there should be 2 new files: train record and test record. At the end, we will train the model. Now the model is formed and evaluated, and this step is done in the first phase train. So we will trace the movement, and this step is done in the second phase test. The movement of such person or object person in the video is tracked via Python script and polluted in OCaml. So our algorithm is divided in 2 steps: train and test. Such as the picture in as input we are a video, then the video is segmented in picture. In the first steps is trained, the second steps is tested. In the 2 steps we are 2 files, XML, then CSV, then record format to use TensorFlow, and the end we evaluation the model. Here we describe the steps. The first step is video segmentation and keyframe extraction. The segmentation of video is the first step in our work. After the segmentation, a descriptive file is granted for each image. Object extraction. In order to be able to implement our algorithm, the images are annotated using the label image package. This annotation consists of listing the coordinate of the boxes containing an object or a person with the corresponding class number. There are a picture of object extraction here. In the picture, we are bicycle and the person, and this is the XML file generated for the previous image. So there are a person, such as the picture, and a bicycle. The third step is creating TensorFlow records. After generating of our annotation and splitting our dataset into the desired training and testing subsets, now we should convert annotation into so-called TF record format. There are 2 steps to follow. First, we should convert the individual XML files to unified CSV file for each dataset. In the second step, we convert the CSV file for each dataset to a point record file. Because TensorFlow Object Detection API does not take CSV file as input, but it needs record file to train the model. Training the model now and evaluation. Once our record file are ready, we are almost ready to train the model. So we need to launch the script train.py, and we should see a series of printouts. After training the model, we can follow it under a web page based on Jupyter, provides information and charts showing the progress of the training. One of the most important graph is the loss graph, which shows the overall loss of the classifier over time. For testing and motion detection, the test dataset provides the gold standard used to evaluate the model. It is only used once a model is completely trained using the train and validation steps. The test set is generally well curated. It contains carefully sampled data that spans the various classes that the model would face when used in the real world. Experimentation and results. The algorithm allows us to browse one video after another. Each video is divided into images to facilitate the detection of the people appearing in each image, then the movement of each. To apply our algorithm, we follow with the following step: organize our workspace and training file, prepare and annotate image dataset, generate TF record from such dataset, configure a sample training pipeline, train and model and track its progress, and finally export the resulting model and use it to detect people. To launch our algorithm, we are testing with 2 videos from this data set. We just need to give it a model main PY, which run the training process pipeline config, and this is the path. There are the video of the 2 video, the table of the 2 video used. The first video is to size 69 megabyte. We are the number of image is 74 and the number of keyframes is 12 keyframes. The second video it divided to 81 image and 15 number of keyframe.
Sorry, you have 3 minutes.
Okay. TensorFlow, creating now TensorFlow record. TensorFlow accepts the data of TF record data. TF record is a binary file that runs fast with low memory usage. It contains all the image and label in one file. In our case, we will have 2 TF record, one for testing and another for training. To make this work, we need to make sure that the CSV file names is matched, current directly is an object detection model research, and click on if the path to data directory is the same as database URL below. Training the model and evaluation. Once our record file are ready, we are almost ready to train the model, so we need to launch the script train PY, and we should see a series of print out similar to the ones below, such as the picture. It is the output of training the model. Testing and detection and motion detection. The test dataset provides the gold standard used to evaluate the model. It is only used once a model is completely trained. This is the picture of testing model. There are the person are detected and boxed via label image package. And the following diagram shows the movement of 2 objects, 2 persons selected randomly by the algorithm during the video. The motion is detected according to change of the pixel position of an object or a person from one image to another. As conclusion, the purpose of this work was to create a method that combines detection and tracking algorithm to track object or people in a video. More precisely, we use TensorFlow for this goal. Our future work is to complete this algorithm in order to extract semantic features from the video and to record them as ontological entities with a formal relationship. We will improve the resulting ontology by integrating the moves and action rules. Example, injecting the dynamic dimension and the video streams into the ontology structure. And thank you for your attention. Any question?
Thank you very much. Any question from the audience? Yeah, I don't see any. Yeah, I don't see any question. So it just my question is about real-time tracking. So so for the moment you are playing on videos that are registered. Would it be possible to apply it to real-time tracking?
Sorry?
So real-time tracking, where, for example, you have a video that is streaming real-time.
Yes.
Will you be? Is there any possibility for you to do this?
Now I cannot this, but it is the future work with my Dr. Ali Frihida. We work about the spatial and real time.
Okay.
Thank you.
Okay. Any other questions? If not, thank you very much. And we will go to the next presentation, which is, I think, the last one. So here I call Rashid Ait Moulay, Abdul Latif Al Ghazi, and Zain Al Abidin Abdul Ali. So to present their work on machine learning and data mining methods for hybrid IoT intrusion detection.
Okay, I am present. I will share my screen.
Yes, please go ahead and share your screen.
Okay.
Bornia, can you please unshare your screen? Stop sharing your screen. Okay, thank you.
Wait, I have to. I have to quit and reconnect because I have some configuration to do to share my screen. Okay.
Okay.
Okay. Okay. Can you hear me?
Yes, I can hear you. Please go ahead and start.
Okay. Okay. Check one time. I think so. It takes so much time. I will just me to the last one.
Hello, we cannot hear you clearly. Can you?
Can you hear me or not?
Yes, now yes. Please go ahead.
No. Okay. Thank you, Chairman, dear colleagues. In this presentation, we will share our vision about combining two aspects for securing IoT devices by using IDS and honeypot to detect attacks in their beginning and before compromising other devices. For a little background about ourselves, my name is H. Mulay Rashid. I am a student researcher in the University of Mohammed V in Rabat, and I have about 10 years of experience in software engineering. Currently, we are working on non-IDS to secure IoT devices. It is my first time here at Cloud Tech Conference. My colleague in this work is Ilghazi Abdellatif. He is a professor at International University of Rabat. He worked on multiple subjects like cloud computing, IoT, and artificial intelligence. So in this presentation, we will start with a brief definition about IoT, honeypot, and their evolution. Then we will talk about different types of IDS. After that, we will discuss about our prototype architecture and system composed of anomaly-based IDS using neural network, intelligent interaction honeypot, and the signature-based IDS. And in the end, we will conclude our presentation about future work we intend to do in order to protect IoT devices. The advances in this industry helped in the growth of this technology that has become so mainstream in our life, with utilities like smart TV, smartwatch, sensors, and actuators. The IoT devices share market is estimated to attain $1.1 trillion by 2025, with compound annual growth reaching 24.7% each year. Many of IoT devices use proprietary systems and protocols, which make them hard to protect. IoT devices are used in many sectors such as healthcare, where hospitals are becoming more dependent in using these devices to monitor patient health, industrial facilities, supply management and logistics, where companies like Decathlon and Alibaba use RFID tagging to ensure delivery of goods to vendors with 100% time accuracy. For the retail, like Amazon Go, use it sensor and camera to reduce screen time with no human cashiers. IoT security is a hot topic these days, especially with massive attacks on IoT devices, as in the case of Stuxnet, originally aimed at Iranian nuclear facilities, then evolved to target industrial and energy producing facilities. With the version malwares on IoT devices, like Mirai botnet, where the authors exploited default credentials used in routers, DVRs, and CC cameras by scanning the internet in order to spread in internal networks where these devices are being used. This malware still remains dangerous because after leaking, many variants has been created. The first time the honeypot was created was in 1997. It is a deceptive tool that tries to incite attackers to penetrate other systems without authorization. This system can help collect samples to analyze them in order to gain further insights. We distinguish two types of honeypots. The low interaction, which is basic and naive honeypot that simulates open ports, application services in order to attract attackers. The advantage of this system is that it is secure since attackers do not have the ability to exploit the system itself. But its disadvantage, it is easily detectable by attackers because it is very naive and it doesn't respond. It only log the attackers and it only log the attackers and block them from accessing the system. For the other type of the honeypot is high interaction honeypot. It uses a complex and real system to engage attackers to get more information about their techniques without making them suspicious. This system requires regular maintenance and deployment. Also, it needs some layer of security because attackers abuse them and control them to attack other systems over the network or on the internet. Building honeypots for IoT devices is challenging, especially because of its diversity and lack of interoperability, which make it harder to trap and entice attackers to send their exploits and 0 days, or to get more information about the techniques used to compromise these devices, especially 0 days. The 0 days attacks are the attacks that have never occurred before. It means new one. So it is it is why we try to use the honeypot to collect many information about these types of attacks. For the intrusion detection system, it is a tool that monitors the network for malicious and abusive activity. This system either notify an administrator about the breach or gather attacks logs using security information and event management to help detect and respond to unauthorized activities, also to distinguish malicious from false alarms. We distinguish 3 types of IDS depending on the analytics and training applied. The anomaly-based IDS. This system is based on a model that is trained with normal network traffic to be able to detect abnormal behavior and evaluate traffic that is not included in this category, like port scan, increase in the bandwidth usage. It can also disseminate 0-day attacks never encountered before and never known in the training phase, which makes it difficult for attackers to access a network without being detected, since this type of system is configured and trained for a network and environment at its normal state. The other type of IDS is signature-based IDS. It uses fingerprints of known threats to identify them. Therefore, it cannot detect 0-day attacks, and it requires recurrent updates of its knowledge database, since we must first know how the attacks are carried out against a network of IoT devices in order to protect it. One of its abilities is that it is not generating a high rate of false positives and negatives like anomaly-based detectors. The last type of an IDS is the hybrid one. It uses both signature-based and anomaly-based detection in order to create a system that takes advantage of the signature generated by anomaly IDS to perform the basic knowledge database update of the misuse detector system to strengthen network security. This enables it to detect more potential attacks with a lower error rate than using either system in isolation. The proposed architecture will be composed of 4 modules: a data collector based on an intelligent honeypot, feature reduction and selection tool, signature-based IDS using online SVM, anomaly-based intrusion detection system installed on the cloud. The goal of our hybrid cloud-based and distributed IDS is to be able to minimize false positives and maximize the detection rate of 0-day attacks for the signature and intrusion detection system based on an online incremental SVM installed on a fog architecture, since it cannot detect novel attacks. This misuse IDS will also use the signature generated from from an anomaly detector system based on an artificial neural network to improve its signature and detection rate of new attacks. This hybrid honeypot is able to collect IoT behavior automatically, simulate real behavior attended by attackers, learn through interaction. It is inspired from practical implementation of hybrid honeypot capable of extending the time of attacker sessions. Initially, it will be naive, but gradually will improve by making updates to its internal database and knowledge using platforms like Shodan, Census.io. This response is collected from the internet will be selected by machine learning algorithms like Markov decision process with the reinforcement learning like Q-learning. A filter will be added to capture payloads and exploits sent by attackers after believing they are interacting with real IoT devices to be stored for future processing, send them to signature database, which is used by our misuse and Trojan detection system. As the data increase in volume and velocity, we need to include big data tools like MapReduce to process the constant flow and large quantity of data captured by the interactive honeypot and anomaly-based IDS. For data optimization and compression, we will use PCA, principal component analysis, to allow the online SVM be more adaptive and respond swiftly to new attacks without much delay. Our anomaly-based IDS will use a multi-layer perceptron to train our model for the normal behavior of our network. We will capture the normal traffic of our testbed composed of multiple smart bulbs, smart TV, and the temperature sensor. After we train our model offline, we will proceed on the online phase where we will install the MLP-based IDS on a cloud server to validate traffic classified by online SVM IDS as normal to make sure no new attacks have passed undetected. If otherwise, the behavior IDS will update a database of signature after being processed by the PCA. This technique will help reinforce the misuse IDS and increase its detection rates of zero-day attacks. The signature IDS will permanently update its attack signature by using an online database where the data coming from an intelligent honeypot and behavior IDS are processed by feature selection model. We will rely on an online incremental SVM on a fog architecture installed on a Raspberry Pi to capture unknown attacks on internal network by having up-to-date data coming directly from the internet. For the conclusion, IoT application heterogeneity makes it difficult to guarantee security and privacy. By using intelligent honeypot, we intended to make the misuse IDS capable of detecting zero-day attacks before it will be used on the internal network. We used PCA with MapReduce to process faster data without much delay, and after that, we send it to the signature-based IDS. Our future work will be the implementation of this prototype and maybe use a deep learning algorithm instead of the multi-layer perceptron to detect abnormal behavior accurately and swiftly in the cloud. Thank you very much. Any questions?
Thank you very much. Any question from the audience? No. No, I don't have questions, but it would be nice if anyone, I mean, I don't know, anyone has question? Okay, so if not, I would like to thank all the speakers. I think we are done with the 4 presentations. One of the presentation number 3, which is the 5th one, did not show up. So with that, I would like to close this session. I would like to thank the presenters, thank the audience, and thank the organizers. Thank you very much. Have a nice day. Bye-bye. Bye-bye. I will close the meeting.
Bon appétit.
Bye bye. Nice day.